Our class today we'll look at revenue analysis. Now, what is a revenue? It's a total income received from a sale of a product. For total revenue, TR is denoted by P times Q, where P is the price per unit and the Q is the quantity sold. AR is the average revenue. So average revenue is given by total revenue over quantity. In most cases, it's equivalent to the price. It's equivalent to the price. Okay, so now we're going to look at an example that will understand how to compute that in terms of an applied question. So total revenue is the revenue that is usurped from a sale of a product. And we looked at our differentiation yesterday. Say if you have y is equal to 10x to the power 5. So the derivative is differentiating the y over the x. So we're talking about the letter on the left side divided by the letter on the right side. That is the y over the x. This is a change in y over change in x. Then you multiply 5 times 10. Then you subtract 1 from the power, which is 5 minus 1. So our final derivative is called 50x4. 50x4. This is how we differentiate. So 5 times 10 is 50. Subtract 1 from the 5, we get a 4. So that's how we find the derivative. So if you have P is equal to 10 100 minus 2Q. So differentiating, this is the P over the Q. Because there's P on the left side and Q on the right side. So whenever you're differentiating a constant, it is 0. And differentiating 2Q, it is negative 2. So you need to understand how these derivatives come about. So we gave examples of number of figures we can differentiate. Okay. So suppose we have 10Q, 10Q squared, 10Q half, 10Q3, 10Q5. Let's differentiate these ones quickly. So the derivative of a constant is 0. So when you differentiate 10, it is 0. 10Q is 10. Because it's the 1 times 10 is 10. 1 minus 1 is 0. So you remain with the 10. 10 cubed 2, what's the derivative? 20Q. But 10Q half times 10 is 5. Q half minus half is negative half. All right? Try this one now. Differentiate 10Q3. What is the derivative, Esther? Basically, the coordinate setup, they shared cubicles or the separate options. So what's the derivative? 30 times um 30 times 3 times 10 is 30. Then subtract 1 from there, becomes what? 2. Try to differentiate the last one. 10q5. What is 10q5 when differentiate it, Esther? Multiply 10 times 5. Because this is important before um, we proceed. What's the derivative of this one? 10q5. Try. So multiply 5 times 10, which is what? 50. Then subtract 1 from the 5. That'll be 4. All right. So with that being said, we're going to use this principle. If the price is given by 170 minus 5q. So find the total revenue. It's 170 minus 5q. Then you put the q outside. So 170 times q is 170q. But it's 5q times q, it's 5q squared. Okay, so meaning our total revenue will be 170q minus 5q squared. So when you differentiate the total revenue, it'll be dtr over dq. So the name now changes from total revenue to marginal revenue. So what is the derivative of this one? Our marginal revenue is equal to 170 10 q. So this is how we differentiate that. Okay. So now, when you're asked to maximize this, how to maximize revenue? Maximize revenue by equating to 0. So when you equate this to 0, 0 is equal to 170 minus 10q. So when this one comes inside, you make q subject. Let's solve for q. So what do you do? Let's solve for q. We divide both sides by 10 by 10. So this cancels that. So our q is therefore going to be 17. So this is the output that maximizes our revenue. Then you substitute this in the actual original price to find the price that maximizes the revenue. So when you put our 17 there, we're going to have our price to be 85. So we are learning how to optimize price using what? Calculus. Okay. So let's proceed and try to use another example. How do we maximize? Okay, let's look at the average revenue for that one. So average revenue is total revenue over quantity. It ultimately come back to be as price. So what was our total revenue? Our total revenue was what? 170Q minus 5Q squared. 170Q minus 5Q squared. So this is our total revenue. To find our average revenue, we divide our total revenue divided by what? Quantity. So to be quicker and easier, you are going to spread the quantity on all the units there. So we're going to have what? Divided by Q divided by Q. So this will give us 170 minus 5Q. This ultimately is the same as the price that we had initially. So in a perfectly competitive market, you'll discover that the price is the same as what? Average revenue. Okay, it's the same as the marginal revenue. So this is in a perfectly competitive market. It looks like it's a straight line. So we are looking at revenue analysis and we're trying to gather up facts on how to maximize our, our return, how to maximize our revenues in short. So marginal revenue has been given by the TR over the Q. So it is an additional unit increase in revenue with respect to price. So suppose we're given our price is equal to 1000 minus 4Q. And you're asked to find four things. Number one, you're asked to find total revenue. Number two, you're asked to find marginal revenue. Number three, you're asked to find maximum quantity. Number four, you're asked to find maximum price when maximize. Number five, you're asked to find what? Average revenue. How do we find those things? So total revenue is equal to what? Price times quantity. Quantity is never given, you impute it. So we're going to have 1000 minus what? 4Q. And outside, we're going to, in brackets, put the Q. So our ultimate figure there will be 1000 Q minus 4Q squared. This is our total revenue. Our marginal revenue is when you differentiate the total revenue with respect to what? Quantity. So the TR over the Q is called our marginal revenue. So 1000 Q becomes 1000. 4Q squared becomes what? 8Q. And how do we maximize? MR maximized, we do what? We get to 0. 0 is equal to 1000 minus what? 8Q. So find the value of Q, we bring this one on the other side. We're going to have what? 1000 divided by what? 8. So the value that will maximize our revenue in this case will be 1000 divided by 8. What do we get? 125. So this is our output. So to find the price, you go back to the original price function, 1000 minus 4Q. Where there's Q, we put what? 125. So it will give us our 500 as our final answer. Average revenue is same as the price. Average revenue, anything average is what is divided by what? Quantity. So total revenue, when you divide it by quantity, it becomes average revenue. So our total revenue was 1,000 Q minus 4Q squared. So you split the Q, and this will take us back to this. So divide that, you're going to have what? 1,000 minus 4Q. This will be our final average revenue. Then we go to some cost analysis, which you looked at yesterday. So cost is a breakdown of, it's a composition of two things. It shows cost of producing an output. The total cost is equal to total fixed cost plus total variable cost. The total fixed cost is constant regardless of output. The total variable cost changes with output. So our average cost is when you divide the total cost by quantity. And marginal cost is when you differentiate what? Our total cost with respect to quantity. All right, so if we have TC is equal to 100, 10 plus 2Q, 10 plus 10Q minus 2Q squared. So the total cost here has two components, the fixed cost and the variable cost. Our total fixed cost is what? The constant part, which is a 10. Our average fixed cost, like I said, average is anything what? Divided by quantity. So it's a total fixed cost over quantity. So it's our 10 over Q. And our variable cost, the variable cost is a component that has what letters? 10Q minus 2Q squared. Right? Average variable cost is when you divide the total variable cost over quantity. So here, 10Q minus 2Q squared. So here we divide by Q, here divide by Q. What we have will be 10 minus 2Q. This is what we call our average variable cost. And also find our marginal cost by differentiating this total cost function. So we find our marginal cost, we differentiate total cost with respect to quantity. So marginal cost is equal to what? Derivative of 10 is 0. Derivative of 10Q is 10 minus 2Q, 2Q2. So 2Q2, when differentiate it, it will be 4Q. So to minimize cost, we equate it to 0. So minimum cost, we equate it to 0. So 0 is equal to what? 10 minus 4Q. So when this one goes aside, we're going to have 4Q is equal to 10. So the Q here is 2.5. For cost, we are looking at minimizing. We don't maximize costs. Okay, then maximize costs. Are we together so far? Then we look at profit. Profit is when we do what? When we find the difference between our profit, our total revenue and our cost. So the difference between total revenue, and cost is called our uh, profit. So if we have our price as 170 minus 5Q, so find out total revenue as this figure here. So 170Q, 170Q. 5Q will be 5Q squared. So that is how the total revenue is. The total cost has already been given. So we need to fuse this in there to find our profit function. So our profit function therefore will be what? 170Q minus 5Q squared. And our total cost will be what? 40 plus 50Q plus 5Q squared. So I need to expand this now here. 170Q minus 5Q squared minus 40 minus 50Q. The subtraction here will make everything negative, minus 5Q squared here. So you put the like terms together. So 170Q minus 5Q squared minus another 5Q squared is 50Q minus what? 40. So 170 minus okay, so 170 minus 50Q. So 170 minus 50Q, how do you get? 120. And minus 5, get minus 10Q squared. And here minus 40. All right, so the profit function is given by this. So now this is our profit function. So to maximize profit, we have two formulas that we can use. Number one, you differentiate and equate it to 0. So the profit over the Q, you equate it to 0. So this is our margin of profit. So when you differentiate this one here, what is our 120Q? It is 120. What is our 10Q squared? It is 20Q. What is our minus 40? It's a constant, it drops out. So when this one comes inside, we're going to have 20Q is equal to 120. So we divide both sides by what? By 20. So meaning, in this case, our GT, therefore B equal to 6. And our price, you substitute where there is a quantity of 6. So this is 170 minus 30, which is 140. So price is 140, our quantity is 6. All right. Are we together? So this is how we maximize profit. This is how we maximize our profit. All right, so now we go ahead and look at how to maximize profit when you are given two functions, the revenue function as well as the cost function. So alternatively, you could have just equated the marginal revenue to the marginal cost. And if they asked you to find the actual profit, you simply substitute this quantity in the Q there. So we're going to say 120Q. So where there's Q, put 6, and 10Q, 6 squared. And you evaluate the answer there. Okay, so our question now is to answer question number 7. Question number 7, we are asked that we're given a total revenue function and the total cost function. So we're being asked to find the output that maximizes profit. So I hope you are familiar now with how to maximize, how to come up with a profit function. Let's do a quick recap. What's the formula for profit? What's the formula for total revenue, Chipo? Total revenue is called what? Price times quantity. What's the formula for total cost? Total fixed cost plus what? Total variable cost. What's the formula for the profit? Profit is called what? Total revenue minus total cost in brackets. So the profit is simply the difference between how much you're earning and how much you're spending. So graphically, profit exists. So this is our marginal revenue, our total revenue, this is our total cost. So total cost and total revenue. Point at which total revenue exceeds total cost is called profit. So profit will range between point A and point B. When profit is more than revenue, when revenue is more than cost, we call it a profit. But whenever the cost is on top of revenue, that is a loss. So the loss is a negative in here. So this is an exam question that we now need to tackle. So determine the level of output that maximizes profit. So we first need to understand the profit function. So profit is given by total revenue minus total cost. So what is our total revenue? We're given as 22Q minus 0.5 Q squared. And always remember to open brackets. That's why I've put them in brackets in the formula here. Our total cost is what? 1 over 3 Q to the power 3 minus 8.5 Q to the power 2 plus 50 Q plus 90. So the effect of the bracket is that it will negate everything that is negative and everything that is positive, and everything that is negative becomes positive. So we maintain here this is 22 minus 0.5 Q minus 1 over 3 Q3 plus 8.5. Why is it coming plus? Because the negative and the positive here. 8.5 Q squared, then minus 50 Q. What happens to the 90? It becomes what? Negative 90. So now we go to the like terms and unlike terms. So 22Q will be matched with what? 22Q will be matched with what? Minus 50Q. Then minus 0.5 Q squared will be matched with what? Plus 8.5 Q. Then minus 1 over 3 Q will be matched with what? It will be alone. Then minus 90. So you need to evaluate there. So 22 minus 50, what do we get? Is 28 Q negative. Then 0.5 Q squared plus 8.5 Q squared, we're going to have there plus 8Q squared. Then here minus 1 over 3 Q to the power 3 minus 90. So this is our profit function. So to maximize profit, we differentiate this and equate to 0. And this is a quadratic equation. So this is where our first session will end. Our second session will now be evaluating quadratic equations. So 28 plus 16 minus Q squared. So this can be solved using a quadratic equation where you're going to find two values of Q, then we'll test them and see which one will maximize our profit. So this is where our first session ends. We'll start another session later.